Hey everybody, my name is Damon Moore. I'm the Executive Director of Oyster River Ecology, and I wanted to give you a quick presentation on some new oyster restoration techniques that we're putting together. One's called Vertical Oyster Garden Anchors or VOGAs. The other one is Oyster Rag Pots or ORPs. So what is a VOGA? It's very simple to make. They're basically a 12-inch landscape pin. We also used 18-inch. Same thing, we also make them with bamboo sticks. To those, you add oyster shells with holes drilled through the center of them. We also make them with sections of cabbage palm stalks, and then we'll also make mixed ones with cabbage palm stalk and oyster shell themselves. So those are slid on the stake. It looks like a kebab, and those are basically stuck into the river bottom and serve as that hard material for larval oysters to attach and start growing a new reef. An oyster rag pot is very, very similar. The same thing with a pin or a metal pin or a section of bamboo to serve as the anchor. That's these they're put in with a internal spacer. We either use two sections of bamboo or we've also used just like bamboo plates that look like coasters. To that we add a cotton rag that's been dipped into a cement mixture. It's hung upside down to cure and creates a nice little pot with a anchor that sticks out of the bottom of it with a ton of surface area, and really excited about how these. So just a little bit on how these work. They're installed into the bottom. We're putting them in on 1 foot centers into our permanent restoration site in the Manatee River. From that, the oysters attach and start to grow. And the concept being that they grow off of that initial basically skeleton that we put together and coalesce into one uniform reef, letting them really kind of take ownership, that them being the oysters of that the term ecosystem engineer, which they're known to do this. So we've seen this sort of activity already in the Manatee River. When I was at Manatee County several years ago, project where we put basically dish trays full of shell into areas of the river just to see how those areas would react if we added that culture material back into these areas that we suspected would be highly suitable for oyster restoration. So you can see here, it's just a standard restaurant dish tray and about a bucket and a half of just recycled oyster shell that came from restaurants. See Jay there was pulling some straws and stuff out of there. This one was put in by the Carlton Arms site near the Braden River. Same area, you can see the apartment complex right there. As we kind of go under and look at this same deployment site, um, the oyster growth was just phenomenal. In just 15 months, these were just covered with 3 to 4 inch market size oysters already there. Tons of mussels, tons of life just using these. Everything we want to see out of oyster restoration. We could see it. You could see a couple of bird footprints there where wading birds had been coming over to forage next to these on the low tide. Some kind of burrowing fish right through there, but just phenomenal growth of oysters on these things. So we were really excited to try and scale up our efforts to reintroduce culture material. Also, kind of just inspiration from what we've seen out in the river. The photo on the far left that looks just like a clump of oyster there. That was, what we were seeing very nearby our permanent restoration site was where there were derelict crab traps that had been left out there, and they were just absolutely coated with oysters and sloughing oysters off to the side and starting to build their own small oyster reefs. We actually saw this when we went out and just were able to locate a lot of subtidal oyster reefs upstream in the Manatee River, a little bit upstream of I-75. And you see all these like small little blue polygons there. Those were small oyster reefs that we were able to map out. But in a lot of those oyster reefs, when we kind of dig through the center and try and figure out what they were composed from, you'd find little pieces of old crab trap in there. So, we were really seeing that like it's a culture limited system. We just really need to add this back. In these areas, these oysters grow phenomenally well. So we just need to kind of basically build them a skeleton to start growing a reef from again. So knowing that, we wanted to put together a prototype test with a couple of different methodologies to do this. This diagram that you see here below, this is something we put out in, I think it was March or April of 2024. And basically, it's the 12-inch shells on a metal spike. Several versions of Voga, some with palm, some with shell, some with burlap. We tried some with just wood spikes only to see if that would work. Some with only palm. The cotton dipped or CD is cement dipped cotton on 12-inch wood spike. That's the ORP. That's what we're calling those now, oyster rag pots. But also tried some traditional methods, being like just cinder blocks, like concrete blocks. We did those both with holes facing up and holes facing to the side. We did just lime rock riprap. Poured some a couple of buckets full of that down, and then same thing. We just dumped some recycled shell down there, and just left those out there in this test plot to be able to come back to and see what that would look like. So our test plot area is at the corner of our restoration site. You can see this is in the Manatee River. It's just south of Colony Cove, basically in the middle of the river, east of 75 a little bit there. So you can see this is the right before we put everything out into the water. The only thing that's not the same as in the water is we did not leave the oyster shell in those bags. We put the shell down loose. We just used the bags to transport. But basically, this quick video here shows you once we got the test plot laid out, what these things look like. So starts here with the just loose oyster shell, not in a crate or anything like that, just poured onto the bottom. You can see it's fairly silty, softer sediments in this area. This is where we had just put the lime rock riprap. These are about the size of cantaloupes or fists. Obviously, cinder blocks, holes to the side, cinder blocks, holes up. This video just the video goes through all these. This is the one that with just the bamboo sticks by themselves, no other treatment put onto those. This is bamboo sticks with palm frond sections. And these are the oyster rag pots. Half of these were made with wooden spikes, and the other half was made with metal spikes. See this one that's shaking here a little bit. This is very, very light treatment of cement. This is burlap that's dipped in cement and then put onto a spike. Metal spike with palm frond only, with everything held kind of straight in line. And then the other ones here are, this is an 18-inch metal spike with shell only. And these are the 12-inch metal spikes with shell only. So when after we came back and did a check on these after 79 days, and you see this is what the shell only looked at. We have um, good spat recruitment where the shell was exposed. Our issue on this site is sedimentation. Most of the shell that was replaced there originally kind of made its way into those sediments. So really, if you're going to try and do this in this portion of the river with shell only, you're going to need to use more than 6-inch thick placement of shell. Very similar situation with the riprap. Where it was exposed, it did really well, especially where there was kind of um, crevices and cracks that predators weren't able to easily get into. But same thing there. If you're going to do this with riprap, you'll need to use more than a 6-inch thickness layer. The cinder blocks, kind of as expected, they did really well. It was interesting to see that the cinder blocks that were placed with the holes up, they did work their way into the sediment. You can see on half of it, it was more than half the width, or half the width of the cinder block that did sink in there. But everything that was remained exposed had really good oyster recruitment, lots of barnacles and everything else in there. The ones with the holes to the side, while we did not have as much settlement, that the big open exposed spot, there was a lot of just sediment that would end up on top of that. So you can see just by holding it, that there was not much oyster recruitment on the actual top flat surface that way either. So it was a good lesson learned on there that you need to have a lot of vertical surface for spat recruitment in these areas. The bamboo sticks, very, very low spat recruitment on there, spat or larval oysters. But you can see there are some there. That was they settled into the sediments a little more than we kind of expected them to. But we're going to keep an eye on this because this is an interesting concept. Because if this does work, obviously this would be an incredibly cost-effective mechanism to be able to try and do oyster restoration. Palm only, again, the spat recruitment was lower, but it was certainly there and higher than just the sticks only. I think they really like these kind of crevices that they can kind of get into and start growing to have some initial protection from predators. I think importantly, we did not notice any degradation of the integrity of the palms at this time. That's an interesting thing compared to pine stakes that we did on a separate test where boring worms really just tore the pine wood apart very quickly. So palms seem to be palm and bamboo seem to be much more resistant to that. The oyster rag pots. This was incredibly encouraging for us because we had really, very high spat recruitment, as you can see on the photographs. The sedimentation was very, very low. As of now, this is, we're aiming to scale up our efforts using this method. The costs involved and the effectiveness of this design seems to be really pointing us that that's the direction we need to go. Another method we had tried there was just to take burlap and dip that in cement and then kind of ribbon that over these spikes. Very, similar, very high with the spat recruitment. Sedimentation was also very low. The kind of the downside to this is that it's very challenging to get it to hold that form. You have to make that ribbon and then staple it in place. So the costs on the production side are going to go up for that. So kind of keep it in mind, but we like the oyster rag pots a little bit better than this method now. On the VOGAs themselves, this was just shell only. On these, you can see we really good spat recruitment. The challenge with this was that we did have a lot of these where the sedimentation was becoming an issue, and a lot of these were burying a lot of the shell. So this, don't want to give up on this method. I think there's definitely applications for this, maybe even in subtidal areas where you're trying to or intertidal zones where we're trying to grow oysters where they're going to be subject to a little more wave energy than we are on this site, but less sedimentation issues. But definitely, some takeaways. Still a valuable method, but maybe not the best one we can do at this site just yet. So as far as how we install these, this is basically we load everything up onto floats like this, and we tow these out. We're working with a partner, Colony Cove. The community there has partnered with us, allowing us to use their shoreline directly adjacent to our reef sites, which is a huge help. We put them on the floats, we tow them out. This video shows installation of the VOGAs, where very, very simple, very satisfying. You basically just stick these into the bottom of the river like you're seeing in this video here, and do your best to get them right at about 1 foot centers like that. And we haven't had any issues with them really toppling or anything. It's just sedimentation with these has been a challenge. So this is really the main purpose of going through all this work is we're really trying to find ways to do oyster restoration in this area the most cost-effective way we possibly can. As far as material costs themselves, the VOGAs are about $1 a piece. The ORPs are about a dollar. The differentiation comes in labor costs for the assembly of these things. With the VOGAs, putting a hole in each one of those shells takes up a lot of time. But between both methods, both of them are very cost effective. When we taken into account basically the the pilot projects I've done now, watching the labor costs to install and to assemble these things, we're looking at about $3 to $5 per unit, and we're putting those in at 1 foot centers. So that's basically one of those 43,560 of those would make an acre there. So when we're looking at doing 10 acres at our site, and then up to 100 acres in these other areas in the immediate future, we're excited to see that these methods are working. They're scaling. A lot of other prototypes kind of came out of what we were doing with here. Some of them just aluminum cans, stucco on sticks, lava rock, pumice stone, wire tubes, just the pine stakes that I mentioned before, and then just cement dipped palm sections like that. Um, there's pluses and minuses for each of these, but some of these were just a little challenging. Cost bump some of these things out because the stuff starts to get expensive. So anyway, just wanted to share that with you. Right now, we're looking to scale up with the oyster rag pots. If anybody's interested in helping that out, if we're conservatively saying $5 per square foot. If you wanted to donate, we'd be, your $5 would get 1 square foot of oyster reef, and we can do the math as high as you want to go with that stuff. So, anyway, I appreciate you listening, and have a great day, and we'll catch up with you later.